Good evening. Today we are going to solve NPTEL assignment number 1. Already you are being with this assignment. You can check your answers. Whatever you have solved are correct or not. Now we have first question. Consider the I-beam in the figure below and the beam support concrete slab. So we have this as concrete slab. That is 3 meter by 0.12 meter. And thickness 120. Further, a 3 meter high wall with 0.35 meter width and directly over the top flange of the beam. Determine the loading on the beam per unit meter length due to the weight of the slab and the wall. So we have to find per unit meter. So we have 3 dimensions. Now if I will talk about slab, so we have 3 meter by 0.12 meter and we have length along this. So when I will find a unit weight, so it will be a rho into G into A because rho is given. Otherwise we have that as W into A, which is weight density. Now mass density is given, so we have to multiply by G. And therefore if we will calculate total weight on beam, then we are going to get that will be weight due to slab plus weight due to wall. Now formula we have this, so we can have this as rho GA of slab plus rho GA of wall. Now rho for slab, so that is given 2400 kg per meter cube. So we have 2400 into 9.81 into area of slab we have 0.12 into 3 because it is kg per meter cube. So now it will be Newton per meter cube. I will divide it by 1000. So it goes to kilonewton per meter. Plus we have 1800, that will be wall mass density into G, and dimensions of wall we have thickness 0.35 and height 3 meter. And again it will be divided by 1000. And if you will solve this, then we are going to get 8.475, which will be unit weight, which will be weight per meter due to slab, plus 18.54, which is weight due to wall, and this value comes 27.01 kilonewton per meter. So your option is A, 27 kilonewton per meter. Now we will go to second. We have to calculate the maximum bending moment at A and the vertical reaction at C. There are internal hinges at D and E. So here we have internal hinges. So we will have reaction at C. So we will have this as VC. Now we know about internal hinge. Moment from left and right are 0. So we will consider a right part of C. So right of E. Moment about E0. And therefore we will get minus VC into 6, no load. So we are considering only this portion VC. And we have hinge over here. And then minus VC into 6 equal to 0. We will get VC, or they are saying that is CY, which is equal to 0. Now we have to find MA. So we have to find reaction at A first, and then we can go for MA. And to find reaction at A, we should know reaction at B. That is, I will mention now BY, as it is they have mentioned CY. So now we will take moment about D0 and we will consider a right part of D. Right of D, and then we have moment about D equal to 0. So we are going to consider part that is this is 0. Then we have here internal hinge, which will be E. This is C, 6 meters. Then we have reaction B, that is BY, which is 2 meter. Then we have load of 30 kilonewton. And this is D hinge. And we are interested first to find By. So moment about D0, and then we will get it as, we are considering right part. So minus, or as it is equilibrium equations, so we can consider clockwise, anti-clockwise, clockwise plus. So 30 into this is 2 meters. This is 2 meters. So we have 30 into 2 minus By into 4, and that is equal to 0. And we will get By, that is equal to 15 kilonewton. So By we have 15 kilonewton, and that is upward. Now total load is 30 kilonewton. So we have summation Fy0, and therefore we have Ay minus 30 plus By, and that is equal to 0. And therefore we will get Ay as 15 kilonewton. Now we will consider left part of D. So left part of D. And by considering left part of D, we are going to get it as, so we have this will be Ay 15 kilonewton, and then we have this as Ma, and this is 6 meter. So this is D. So we can have moment about A equal to 0, and then 15 into 6 minus Ma is equal to 0, and therefore Ma 90 kilonewton meter. Again we have anti-clockwise. So we have option Cy0. So option is C. Now we will go to the third problem. So now in this we have given A and D are pinned and supported. B we have that is fixed connection, that is rigid connection we can say, and C is internal hinge. So first we will consider downward part of C. So we have this will be C, because moment about C from left and right we have 0. So we have here dx, and then we have dy. Now if we will take moment about C equal to 0, then we are going to get dx, and this is 6 meter into 6 equal to 0, and our value of dx that is equal to 0. Now if we will consider total, now we have this will be dy, and now we have this as dx, which is equal to 0. Now we will consider whole frame and take moment about A equal to 0. So we have minus dy into, so we have 2 plus 1.5 plus 1.5, that is d into 5. Then we have plus 25 into 1.5 plus 20 into 3.5 plus 7.5 into 4 into 2, and that is equal to 0. And by this we will get value that is of V dy, and that value we will get 33.5 kilonewton. So we have dx 0, so option is B, and dy 33.5 kilonewtons. Then we have next calculate the bending moment at A. So now in this we can have total load will act at centroid, and we have this value 1/2 base into height. So we have this value as WL by 6. Now we are interested to find bending moment at A. So now we have this distance that will be 1/3 of L by 3, and this comes L by 9. And therefore moment about A that is equal to WL by 6 into L by 3 plus L by 3 plus L by 9. And if we will solve this, then we are going to get it as WL by 6 into, so we have 3 over here, 3 over here, and 1 over here, 6, 7. So we have 7L by 9. And from this we will get 7WL square divided by 54. So option we have D. Then we have next problem, that is fifth problem. Out of the option below, which one is the correct shear force diagram? There is an internal hinge at B. So now we have internal and hinge at B. So we have a reaction at A will be RA. Or we will say as per their convention AY. And then we can have moment about B equal to 0. So, and consider left part. Now considering left part, if we will consider only 2 meters, then we have this will be AY and this is 10 kilonewton per meter. So we have this as 10 kilonewton per meter. This is B. Then we have moment about B equal to 0 equal to AY into 2 minus 10 into 2 into 1. And therefore we will get AY that is equal to 10 kilonewton. So value of AY is 10 kilonewton. So automatically by using Fy0, we will have value of AY minus 10 into 4 plus dy that is equal to 0. And therefore we will get dy that is equal to 30 kilonewton. So we have AY which will be 10 kilonewton and we have dy that is equal to 30 kilonewton. Now we will plot SFT over here and then we can go for correct option. I have not taken other options. So we have 10 kilonewton. I will go up 10 kilonewton. Then we have at C. So till C we have this will be x to the power 1. So sorry, x to the power 0. So here we will get x to the power 1. So now what will be this value? So this will be 10 minus 40. So I will get this value that is equal to 30 kilonewton. So we will have this value 30 kilonewton. Just I will plot it. So we have 30 kilonewtons. So now I will try to draw this straight line. Yes. So we have this will be 30 kilonewton minus. Then we do not have any load till this and then we have 30 kilonewton up. So we have this will be minus, this will be plus, and option A is the correct option if we will talk about question number 5. So now in this video we will stop for 5 only. In the next video we will go for again 5 so that we can have time duration of videos are less. So thank you.